trigonometry, before we look at the assessment material, we're just going to go through some rules. So if you know sort of 4 or 5 things, this whole topic becomes so much easier. And I don't use the cast diagram. If you've learned to do things using the cast diagram, fantastic, but I don't like them. So I'm just going to show you how I go about doing this. So you're going to learn some rules to start with. So for AS Trig, you should know SOHCAHTOA from GCSE, and then you also have the area of a triangle, which we have, if it's non-right angled, half AB sine C. We have our sine rule. So A over sine A equals B over sine B equals C over sine C, which we can flip over. We've got A squared equals B squared plus C squared minus 2BC cos A. We've got the cosine rule. And then we've got some rules for sine, cos, and tan. So all you need to remember, for sine, it's always 180 minus, cos is 360 minus, and these repeat every 360. So once you have 2 solutions, and tan is the easy one. It's just plus and minus 180. So if you have these rules in front of you, you should theoretically be able to do all the questions. So let's have a look. I think there's 10 questions in this section. Let's go through them and see where we get to. So hopefully, that's on to the end. Let's start question 1. Okay, so figure 1 shows a sketch. AB is 3x, AC is 2x, CAB is 60, given the area. So we just had that formula that we know. The area of a triangle is a half AB sine C. So we know the triangle is 18 root 3 is equal to a half times 2x times 3x times sine 60. When you put sine 60 in your calculator, it will give you root 3 over 2. But if we just go through this, we'll cancel that out. So we've got 18 root 3 equals 3x squared, 3x squared times by root 3 over 2. We've got 18 divided by, so then we can do 18 times by 2 divided by 3, which gives you 12 because the root 3's cancel. So x squared equals 12. So x equals root 12, which is the same as 2 root 3. So nice and easy. And then it says find the exact length of BC. So here we're going to use the cosine rule. So remember, the cosine rule is a squared plus b squared equals, sorry, that's normally, is a squared equals b squared plus c squared minus 2bc cos a. All right, why is it not clearing? Let's try again. All right, there we go. Okay, so this is going to be our small a, and then we can choose either as b and c. That probably just makes more sense. So we've got our a squared equals b squared. Now remember, x is 2 root 3, so that's going to become 4 root 3, and then 3 times 2 is 6, so that's 6 root 3. So we've got 4 root 3 squared plus 6 root 3 squared minus, and I'd always recommend putting this in a big bracket, 2 times 6 root 3 times 4 root 3 times cos 60. Stick that all into your calculator and you get 84. And if you put your square root in, it gives you 2 root 21. So nice and easy, using your calculator, nothing new from GCSE. It's area for triangle, and then it's using the sine, sorry, not even the sine rule, the cosine rule. Okay. So here, I'm going to show you how to use that rule with sine for this question. So we're going to go through. So remember what I said for sine. All you need to know is 180 minus, and it repeats every 360. So before I start, I'm going to look at the range. So I'm going to look for 2 theta plus 10. So to both sides, I'm going to times it by 2, so minus 90 times 2, add 10, which gives me minus 170. And then I've got 270 times 2, add 10. So that's quite important. That just helps you not make a mistake. Okay. So first step, grab your calculator and you're going to do shift sine of minus 0.6. And your calculator will give you minus 36. How many decimals? 1 decimal, we're going to go to 2. So 2 theta plus 10, shift sine minus 0.6. In your calculator, it gives you minus 36. I'm going to round it to 87. Then I'm going to use this rule. Leaving it in my calculator, I'm going to do 180 minus answer. And that gives me 216.87. And now I know I've got those two numbers. All I have to do is to add 360 or minus 360. So let's try. If I minus 360 from this, so I minus 36.87. I'm not going to trust my mental arithmetic still. Minus 360, it gives me minus 396. That is too far out. So we don't care about that one. We're not going to write it down. It's not in my range. 216.87 minus 360, however, gives me minus 143.13. Now I'm going to add 360. If I add 360 to minus 36.87, so minus 36.87 plus 360, it gives me 323.13, which is still in my range. If I add it to 216, it gives me a number that's too big. Now to every single one of these, I'm now going to minus 10 and divide by 2. And so the answers I get are minus 76.6, 23.4, 103.4, and 156.6. And at this point, I'm writing it to 1 decimal place because that's what they've asked you to. Right, question 3. Right, so we know we've got 80. Calculate the area of the lawn to 3 significant figures. Now, to use the area, half AB sine C, we need another side. We've got two angles. We know it's a triangle. So we can therefore find the final angle. So 180 minus 70 minus 60 is going to give me 50. Now using the sine rule, it means I've got these two opposites. I could find either this side or that side. It doesn't really matter. Okay, so let's say we're going to find this side using the sine rule. So I'm going to call that x. X over sine 60 equals 30 over sine 50. That gives you an x, when you multiply it up, of 33.9. Now I can use the area of the triangle. So area for triangle equals a half AB, the x and the 30. I'm going to use the two sides that I know. So 33.9 times 30, and it's sine C. So it's sine of the angle between them, sine 70. Put that all in your calculator in one go, and you get 478. It's an area, so it's meters squared. Why is your answer unlikely to be accurate? To the nearest square meter. Well, you could say because the sides, the lawn might not be totally flat, or I don't know, is not to the right amount of significant figures. It could be more accurate, anything like that. Okay. In a triangle ABC, AB has a length of 10. So let's have a look at this. So we've got triangle ABC, ABC. AB is 10, AC is 5, BAC is theta, Okay, and so we've got the area of a triangle equals a half AB sine C. So 15 equals a half times 10 times 5 times sine C. So we end up with, or sine theta even, sine theta equals, so we can do 10 divided by 2 is 5, 5 is 25. We've got 15 over 25, which gives us 3/5. And then it says possible values of cos. So actually, we know we're probably going to get a plus and minus somewhere. So the rule that we didn't write on that previous sheet that you learn is also that cos squared theta plus sine squared theta equals 1. And we also have, we don't need it in this case, but tan is the same as sine theta over cos theta. Right, so we know what sine is. So sine squared is 9 over 25. So that means cos squared theta must be 1 minus sine squared, which gives you 16 over 25. So cos theta, when you take square root, you get plus or minus 4/5. Then you've got, given that BC is the longest side, find the exact length. Okay, so now we're going to use the cosine rule. So we've got BC squared equals 10 squared plus 5 squared minus 2 times 10 times 5 times cos theta. But we want the answer to be the bigger number. So if we've got a minus there, here, we want to times it by the minus 4/5, because a minus and a minus will make a positive, which will make this whole thing bigger. So then you could put both in and see which one comes out, right? So you get BC squared being 205, therefore BC is the square root of 205. And you don't need to simplify any further. Right, question 5. Oh. Right, so in this question, this is a disguised quadratic. And the way I know that is it's a mixture of sines and coses, and I look for the thing that's not squared, because I know the rule that sine squared x plus cos squared x is 1. So I'm only be able to change the squared one. So I'm going to replace sine squared x with 1 minus cos squared. Plus 7 cos x minus 13 equals 0. Rearrange that, I get 12 cos squared x, cos x plus 1 equals 0. For factorizing, you can just plug it in your calculator and get your solutions. Right, so you've got a quadratic and you end up with cos x. So you plug in your calculator, you go to equation, polynomial 2, and you use the coefficients, 12 minus 7, 1. And it tells you that the two answers are cos x equals a third or cos x equals a quarter. Now remember, the rule for cos is 360. So cos is sorry, let's not x minus, I mean 360 minus x. Let's write it up here. So remember, your rule for sine was 180 minus x, and for cos it's 360 minus x, and then it repeats every 360. So if I do shift cos of 1/3, it gives me 70.53. Now that's not that's not in the range, but that doesn't matter for the moment. Then I do 360 minus answer, and I get 289.47. And then I'm going to do the same for a quarter. Shift cos of 0.25. I get 75.52. 360 minus gives me 284.48. Now remember, we can add 360 and minus 360. If we take the 70.53 and we add 360, we get 430.5. Now we know if we add it to that, it's not going to give us an answer in that range. So we're all good. And we do the same with the 72.52 and we get 743.5. Because Remember, these repeat every 360. Okay, so we've got 2 answers. We're done, dusted. Right, question 6. Okay, question 6 requires you to think a little bit. Right, so we've got AB is 12. BC and BD are both 7. So we know that this is an isosceles triangle. BAC is 27. Okay, perfect. And we want to find ACB. Right, so we could use the sine rule because we've got opposite sides. So we could say sine C over 12 equals sine 27 over 7. So sine C equals sine 27 divided by 7 times 12. So 0.778 something. So shift sign answer gives you 51.102. Then remember, sine is also 180 minus. And we don't know at the moment which one it is. So 180 minus answer. And we get 128.897. And we've got to think logically, which one of these 2 will it be? Now it has to be the bigger angle because this will be the other angle. And if that was 128, then that would also have to be, because it's an isosceles triangle. And then that's impossible because you're going to end up with more than 180 in your triangle. So this one is definitely 128.9. So 128.9. So that's ACB. And if you didn't figure it out here, hopefully you'd realize it in the next bit. Okay. So it says find the minimum length of steel. So we've got one side left to find, which is ACD. But what we can find is the whole of AD, because we know now that this is 51.102, isosceles triangle, so is that, which means we can work out this angle here and this angle. So if we can work out this angle and therefore this angle, and then we have the whole thing. So, sorry, 180 minus 51.102 minus 51.2. This gives you 77.79. And then if you do 180 minus 128.9 minus 27, actually, we didn't need to do that. We only needed the one in the corner because we've got one big triangle. So the triangle that I'm now thinking about, there's nothing wrong with what I did, but it's making life difficult, is we're going to think about this whole triangle. And then we can see that this angle here must be 101.9. So we can use the cosine rule to find A to D. So AD squared equals 7 squared plus 12 squared minus 2 times 12 times 7 times cos of 101.9. Stick that all in your calculator and take the square root. And you end up with AD equals 15.09. But we know that A to C, we don't need A to C. We know we've got A to D plus 12 plus 7 plus 7, right? So we get 12 plus 7 plus 7. So this one, this one, this one, and then the one we just found, because we want all the different sides, and that's going to give you 42 meters. Okay, question 7. Okay, students attempt. Identify 2 mistakes. Right, so sometimes these are a bit tricky to see, but if you have a look and think about what that student's done. It's a 7 part 2. Okay, no, there isn't another bit. All right, never mind. Right, so identify 2 mistakes that the students made. Okay, so if you have a look at tan is sine over cos, so that looks right. Then they've multiplied the cos up, which also looks right. But then if you notice, what have they done? they have cancelled out sine from both sides. Now you can't do that. You can if you did sine x equals 0, but on its own you can't do that. Because if you think about it, if I was to put it all on one side, it's a function. You could take sine x outside the bracket, you get 7 minus 8 cos x, which would leave you sine x equals 0, or cos x equals 7 over 8. Now sine x equals 0 has solutions, right? And now cos x equals 7 over 8, shift cos 7 over 8 gives you 28.9. But remember, so we're going to use those rules. So x equals 28.9, which we agree with. And we're going to do 360 minus. So 360 minus answer, which would give you a solution of 331.04. Now remember, we can add and subtract 360 from these. If I add or subtract from 28.9, nothing changes. But if I subtract 360 from what I just found, I get minus 28.9 as well. So x can be both of those. So it could be 28, or let's round that. So x equals 29 or minus 29. So the two mistakes are not considering sine x equals 0 and not finding the second solution. Okay. Then it says, find the smallest positive solution to this equation. Okay, well, it doesn't tell me what range that it wants it in, but we will assume we're taking this is the same as our x. So our smallest value that we had is we want the smallest positive answer. So the smallest thing, which is going to give us a positive answer. So if we take 4 alpha plus 199, and we were to make that equal to 28.9, that when we minus 1199, it's going to give us a negative answer. So the first positive will have to be 331.04. We minus 199 from it and divide by 4. And hopefully, see what we get. 1.04 minus 199 divided by 4. Yes, we get 33.0. So all we're doing is we're trying all the numbers we have and seeing which is the first one in order to give us a positive answer. Okay. Right, question 8. So I remember marking this in the exam, and this threw some students who overcomplicated life. Okay, it's maybe not obvious, but you use your answer to help you do it. So first steps, we notice in the question, there's a sign, in the answer, there isn't, or in the what the solution. So we're going to replace sine squared theta with 1 minus cos squared theta. Minus 7 cos theta plus 2 over 3 plus 2 cos theta. And the top comes out to be minus 10 cos squared theta, 10 minus 7 cos theta plus 12 over 3 plus 2 cos theta. Okay, and this is where you use your answers. You know that this 3 plus 2 cos theta is going to cancel out. So I'm going to put it at the top. And I know I'm going to be left with 4 minus 5 cos theta. So I'm going to write that, and then I'm just going to check it. I open it out and double check it's the same as above, and it's as if you factorized it. And then you show yourself crossing this out, not literally, like doing that. And you're left with 4 minus 5 cos theta. Okay. So use the answers to help you do that. You could have sat there and factorized it and written it in terms of cos, but this is much easier. We know what we're ending up with. So now we know all of this is the same as this. So we can replace, for part B, the left-hand side with 4 minus 5 cos theta. 3 sine theta. And you'll notice that the 4's will cancel. So we'll cancel out the 4's. We will divide through. We know that sine over cos is tan. So if we divide through, and these should both be x's or both thetas. There's a mistake in the question. I think it says solve for x, so this should really be an x here. So let's change these to x's. So this makes a bit more sense. So we're dividing both sides by cos, and we end up with -5 equals 3 tan x. So tan x is -5 over 3, and tan is the super easy one. No cast diagrams, nothing required. Just plus and minus 180. So shift tan of -5 over 3, which gives you -59.03. And then, or 0.4 even, and then you're just going to add 180 until you end up with solutions in your range. So I get 120.96. Add another one, 300.96. And that's it. I just put a cross through the solution that don't need, and I've solved my equation. Okay. Next question. Let's have a look. Right. Oh, all right. I'm going to make this smaller so you can see it. Okay. So, shows parts. All right. So we know how to do our functions question. If it's inside the bracket, it affects the x. Outside, it affects the y. So this is a normal cos graph, but outside, we're stretching it by 3. It's outside, it's affecting the y's. So instead of a cos graph normally going between 1 and -1, this one is going between 3 and -3. So we know that it normally goes down there at -180. So that doesn't change because we've not done anything to our x coordinates. And the y becomes -3. And then, so that's your coordinates of P. And now, what have we done here? So here, the y coordinate's not changing because that's still a 3 there. So straight away I can write the -3 in. The x's, remember the x's are like ex-friends, ex-boyfriends, girlfriends, partners, whatever, ex-people. They're annoying. They do the wrong thing. So if it says divide by 4 there, what it really means is times by 4. So we're going to take -180 and we're going to multiply it by 4. And we get -720. And now, again, the y's haven't changed in the next one. But instead of minusing 36, we're going to add 36. So we get -144. Okay. And solve. Oh, okay, so that's got nothing to do with that bit of the question, so we'll do that bit in a second. Right, so hopefully that makes sense. Right, so if I clear that, and let's do part C. So here we're going to replace tan with sine over cos. So we get 3 cos theta equals 8 sine theta over cos theta. We're going to multiply up by cos. So we get 3 cos squared theta equals 8 sine theta. Disguise quadratic, replace the cos squared with 1 minus sine squared. I don't know why my s's are doing something weird. Right, let's try again. Sine theta. Open it up and move everything to one side. So 3 sine squared theta plus 8 sine theta minus 3 equals 0. Either factorize, stick it in straight into your calculator to get your solutions. So you get sine theta equals 1/3 or sine theta equals -3. We know that this is impossible, so we're going to put a cross through it because sine and cos always between 1 and -1. Inverse sine of 1/3. So we do shift sine of 1/3 and we get 19.47. We're not going to worry about the range just yet. And then sine is 180 minus. And we get 160.53. And remember, now we have our 2 values. We can just keep adding and subtracting 360 until we get something in the range. So I'm going to add 360 to, just because it's still in my calculator, this one, and I get 520.96. 19.53. If I take 19.47 and I add 360, I only get 379, so I don't make it to the 450. So I've just got one solution. And they want it to one decimal place. So theta equals 520.5 to 1 dp. Okay, final question. Okay. Again, tan. We see tan, we go tan is sine over cos. We're going to replace that with sine over cos, first step. So 4 cos theta minus 1 equals 2 sine theta times by sine theta over cos theta. Right, let's times everything by cos theta. 4 cos squared theta minus cos theta equals 2 sine squared theta. Another disguised quadratic. You look at the thing that's not squared, which is 4 cos sine over cos. Yeah, so you look at the thing that's not squared, which is cos, and therefore you want everything in terms of cos. So you're going to replace the sine squared theta with 1 minus cos squared theta. So you'll get 4 cos squared theta minus cos theta equals 2, 1 minus cos squared theta. Open out the brackets because it's a show that. Got to go for all the steps. And if we move everything to one side, we find we get the answer. Move that over, you get your 6 cos squared theta minus cos theta minus 2 equals 0. Okay, and then it says hence solve. So if we have a look here, instead of cos theta, we've got, so in the original question, instead of cos theta, we've got cos 3x. So we do exactly what we normally would have done, and we stick it into our calculator, and we find the solutions. And when we do that, we get cos 3x this time, though, is 2/3, and cos 3x is minus 1/2. And we want to solve those. We check our range, which is just for x. So we're going to make it for 3x by multiplying it by 3. And then all we're going to do is we're going to do shift cos, oh wait, should put that in, 270, sorry. Shift cos 2/3. And so if I do shift cos 2/3, I get 3x equals 48. Yeah, 48.19. And then I'm going to do 360 minus answer, which gives me 311.81. And then I'm going to do the same for half, shift cos of minus 0.5. I'm going to get 120. So 3x equals 120. And then I'm going to do 360 minus, because that's my rule. I get 240. Okay, now to both of these, I can add and subtract 360, but I realized when I do that for either of these two, it takes me outside the range. So now this one's outside the range as well, so I can ignore this one. And now I'm just going to divide everything by 3 to give me x. So 48.19 divided by 3 gives me, how many does 1 plus, okay, 16.1. 120 divided by 3 gives me 40. And then I've got 240 divided by 3, which gives me 80. And I've got 3 solutions, and that's the end of that section. Right, so hope that's useful. We've got logs, differentiation, integration, and vectors left, which I'll probably do one more now and then the rest tomorrow. So